Welcome back to Bitcoin Season 2, a podcast from Blockspace Media. Bitcoin Season 2 showcases new ideas and conversations from new voices on Bitcoin, the oldest blockchain. We combine technical and cultural discussion often into one conversation. It's a very exciting season for discussion and ideation on the oldest blockchain. Bitcoin Season 2, again, is produced by Blockspace Media. Check out other Blockspace Media podcasts and newsletters, in particular the Gwart Show and the Mining Pod. Subscribe to our newsletter. Go to blockspace.media. That's our website. Sign up for the newsletter. Comes out on Mondays and Fridays. We cover everything from mining company acquisitions to Ordinals to Bitcoin technical discussion. Anyway, I'm joined today by Orkun, co-founder of Chainway Labs, to talk about Citrea, a Bitcoin rollup. So welcome, Orkun. Thanks for coming on Bitcoin Season 2.
Hey, Charlie. Thank you for having me today.
Yeah, so I think I first met some of your colleagues in Miami about a year ago at the Bitcoin Miami 2023 event, and you guys were, and I remember talking to some of them. You guys, as a team, had been working on some other stuff preceding Citrea, ETH, privacy tech on ETH. I think even a bit of some work in the Ordinals ecosystem. Can you talk to me about like some context of where you and the Citrea team came from before really finding your niche in the and working and launching on Citrea?
Yeah. So as a team, actually, we co-founded the company 2 years ago. I'm one of 4 co-founders and the CEO of the company. But 2 years ago, we actually started building privacy technology on EVM chains. We built one of the most innovative solutions called proof of innocence and privacy pools. And then later, early next year, just like everyone else, we discovered Ordinals. And maybe we was a little bit earlier than others. There was only like around 100 inscriptions at the mainnet, and we had a like Bitcoin node in our office. So we immediately indexed our software, which was very fast back then. And then we tried to like inscribe several things and realized the user experience is not that great. So we said we can easily build a wallet around it. It wasn't that easy, but we built a wallet in a month. So we released Ordinal Safe. It was one of the first Ordinals wallets. And I think it's still the like only wallet that supports trustless inscriptions and like BIP signing stuff. And back that time, we know like ZK very well. We know Bitcoin script very well. We know Ordinal space. So what we said, okay, what if we can combine this idea but come up with actual programmability on Bitcoin? And the idea eventually evolved to building a ZK rollup on Bitcoin. And since then, this is our only focus. We already completed the other privacy protocol on Ethereum, and then we also shut down the Ordinals wallet around a couple of months ago because we were focusing on this. And since then, we are just expanding the team, created the brand of Citrea, which I think pretty respected in the ecosystem right now. And yeah, we are building cutting-edge technology on zero-knowledge proofs, Bitcoin script, and BitVM.
Yeah, I think it makes a lot of sense, especially because, you know, I don't know if a lot of people have really kind of fully realized that there's a huge connection between being able to post proofs to Bitcoin and really what Casey defined as the inscription envelope standard. And I think, well, I will come back to that, but I want to pull back and begin at the beginning, because if someone's listening to this and they don't understand what a rollup is, some of our audience, Ordinals people, or even just kind of mining folks who haven't really followed what's happening on other chains, for the uninitiated, what is a rollup? What are the different types of rollups? And then what is Citrea's rollup? So what is a rollup first?
So rollups names coming from rolling up transactions together. So initial idea of building L2s on Bitcoin was like creating side chains, which are very similar to Bitcoin, but they live next to Bitcoin. And the issue is that you get zero to like less security with their constructions because they work next to Bitcoin. They don't get any security from Bitcoin in a meaningful sense, and they don't have proper two-way peg mechanism. And the rollup idea was born in Ethereum ecosystem mainly because, and they said, okay, what if we can actually combine these transactions together, even with a ZK proof or a fraud proof, which I can explain them. Rolling all the transactions in a single succinct thing, and then what if we can verify this thing in Ethereum? So the ZK proofs are the mechanism for you to allow like have a huge computation, but you can run ZK circuit once locally and generate a mathematical proof. So everyone can actually verify that computation without even showing the what are the computation. So in our case, we are just rolling up multiple transactions off chain, and then we put into a ZK computer, and eventually we get a single proof saying that I compressed all these transactions and processed, and they're all valid. So from a Bitcoin perspective, it is not that big or not that computation heavy. But once you verify it, which means you verified all the L2, which gets the ultimate security of the L1. All the L1 mathematically verifies all the L2, which is the ideal work that we want to see. And in rollups, like I said, there are two types. One is optimistic rollups, and the other is ZK rollups. And what we are building is kind of like something in between, because in Bitcoin there is no proper optimistic rollup solution or no proper ZK rollup solution. But what we are building is it works just like a ZK rollup, but the verification part becomes optimistic thanks to BitVM. So we are settling optimistically on Bitcoin and have this trust minimized two-way peg mechanism, but the rest of the rollup just proves every single transaction and inscribes the transaction data of the proof to Bitcoin. So anyone can just take a look, verify the proof locally, and move on.
Yeah, and so you say at a high level, your Citrea sits a little bit somewhere in between this optimistic and ZK rollup. Could you dive a little bit deeper? What does that actually mean? How does that actually work? I know I read the documentation, the blog, and you're still working on the fully building out the implementation. But could you talk more about really how it differentiates from the existing rollup proposals and architecture out there?
Yeah. So in Bitcoin, I don't think there are other rollups actually built on Bitcoin, but the rollup has a single criteria that has to use the underlying chain's data availability. So it has to inscribe enough data to underlying chain, which is either full transactional data or proofs. What we do is proofs. And the difference is in Ethereum, you have Turing complete base layer, so you can easily build ZK rollup or optimistic rollup. But in here, we are dealing with a very limited scope of scripts. And previously, it wasn't even possible to actually verify a ZK proof on Bitcoin. But right now, thanks to BitVM, it allows you to verify ZK proofs optimistically, which means if everyone agrees that the ZK proof is correct, you don't have to do anything. But if someone disagrees that the ZK proof is incorrect, they can always go on-chain and verify ZK proof in two different parts in an optimistic manner. So Bitcoin also know is the proof is valid or not. So using that mechanism, we are building a ZK rollup, but it has the settlement optimistic. So if everything is correct, Bitcoin doesn't compute anything, but stores. If something is incorrect, Bitcoin both stores the data and also computes the computation.
So it's really interesting to think about how we're, a year ago today, no one was even talking about how rollups were really possible. Well, maybe a handful of researchers were, but it was still this big idea. Then Robin and the ZK Sync guys come in and they come out with this challenge response mechanism called BitVM. BitVM has been in development for a while. We'll come back to BitVM in a moment, but I want to focus right now. I think what I haven't heard you talk about, or really many people talk about in the rollup space, rollup on Bitcoin space, is just how this relies or is downstream of Casey Rodamore's idea of creating this enveloping mechanism to post data on Bitcoin.
Yeah.
I know that, again, you guys are still working the actual implementation, but I guess my first question is, are you guys just going to use the exact same inscription envelope that Casey defines, or are you exploring other types of ways of packaging and posting this data to Bitcoin?
Yeah. So the rollup itself has a definition, like I said, it has to use L1 blockchain as a data layer. So it has to store its data on L1. And previously, then Casey's invention, that it wasn't possible to store data more than 80 bytes, right? You could only store OP return, which is limited by the 80 bytes, and no one could actually store anything meaningful. They just store hashes. But this doesn't give you the security. But what Casey found is you can put more data, up to 4 megabytes, if you correlate with miners, to the Bitcoin blockchain. And rollups obviously require more than 80 bytes of data, but it still can fit under 4 megabytes depending on the usage. So what we do is we get the ordinals idea, inscription idea, but change the tag. So it push like OP push ord, but instead of doing that, we just OP push Citrea. Then we serialize our byte proof and state diff data on Bitcoin. It looks like an inscription, but ord indexer doesn't index it. So we don't have to like burden the computation load to the ord node software runners all around the world. Only like people who runs our own software index that transactions. But it is still stored in Bitcoin in the same way. It looks like an inscription, but it doesn't get indexed by the ord software, so everyone's happy.
Yeah, I think this is really interesting because this was a topic that I and some others early on were talking about, which is, a lot of people think, like, now that the narrative is so conflated, people just call these JPEGs ordinals, but it's really need to differentiate between the ordinal itself, which is the SAT, and the inscription, which is just a defined scheme to package this data. So it sounds like you guys are you're going to basically make a Citrea dedicated inscription, index those, and build some kind of interpreter to read the chain and log
Yes.
those, rope that into the rollup implementation.
Yeah.
And I know that there's probably some optimizations you can have beyond what Casey's particular implementation is. Have you are you guys exploring like further optimizations? Like you can make them more byte efficient, I understand. I don't know if you guys have taken a look at that at all.
Yes, we are doing it. So in proofs and state diffs, we can apply generic compression inside the circuit. So we are posting the PEG solutions and others because we don't need to put the actual uncompressed data, because everyone is running a node software. They can just like get the data, uncompress, and then process. So we don't have to deal with all this like unnecessary bytes that we can compress. Yeah, we are always doing it. And our node software simply consists of a regular blockchain node software and also a specific indexer that indexes our own proofs. So it just connects to the network, gets all the data, process all the transactions, and once in a while it goes back to the Bitcoin main chain, finds the relevant inscriptions, and verifies the proof inside them. So it just marks some states that are finalized on Bitcoin and move on.
This might be a basic question, but I don't know how big the average byte size of a fraud proof might be. Is there like an average fraud proof size for Citrea, or is there like a minimum, like an average or a median size? I'm kind of curious about this. I don't really know much about this.
Yeah, so we have like two things that we do. One is inscribing ZK proofs, and the other is settling that ZK proofs. So in terms of the inscribing ZK proofs, it really depends on the usage of the rollup. So if rollups use a lot, then it grows sublinearly. It doesn't use a lot, then it is a bit huge for regular users. But it is very fluctuating. But if you scale, let's say, Bitcoin 10 times more TPS than its existing status, then we only take like quarter of the block, not more. So it is obviously a huge improvement over like existing Bitcoin processing. And the fraud proof side, it is not necessary to execute fraud proofs on chain because they're only executed if there's something wrong. As long as everything is correct, it is just like a regular Bitcoin transaction, less than maybe even like 50 kilobytes or such. So I think it's just a regular transaction. But if we need to put the fraud proof, it is actually quite big. It maybe take a whole block. But like I said, it won't ever get executed for most of the rollups because there's no reason to like fraud because you will get slashed.
Yeah. So we may come back to this, like the block space usage component. I think that's a very interesting topic in and of itself. But let's move on to this bridge design. I myself am still wrapping my head around the multitude of bridges and trying to follow like the bridge discussion. But when Will Foxley interviewed you on the mining pod, I believe you had not yet released Clementine, the actual like bridge for Citrea. And can you just talk to me just about how Clementine works, just at a high level?
Yeah, for sure. So initially, once like BitVM paper came out around October, I think last year, we realized the main potential for it is just to build bridges, because okay, it's a very good like channel connection, but you cannot do much with channels as we see on like Lightning and other channel implementations. But what if we can build a bridge? And we just like fly to the Bitcoin Amsterdam and met with Robin there, ask some questions and like get some ideas for how to build a bridge. And initially he sketched some bridge design, and we took that design and started working on it. And the Clementine is a BitVM based bridge, but it is only an alternative BitVM based bridge. So BitVM itself is not a bridge. I think most people confuse that thing. BitVM just provides a base to build bridges. We have a bridge design called Clementine. Robin has a bridge design called BitVM based bridge, and SuperTestnet has another design called Uniswap. And I think a couple of folks also working on other designs. So in Clementine, what we do is BitVM allows you to get this one-of-n assumption, as long as your light client in it also has one-of-n or like trustless assumptions. So what we do is we just aggregate these proofs from Bitcoin that we previously inscribed and merge them together in a like recursive ZK proof. So eventually you have a single proof that verifies whole Citrea state. That's like I think one of the key innovations that we did. We aggregate these proofs together so that the verification becomes much more easy in BitVM. And then in BitVM, we verify this proof alongside with multiple other stuff, which are mainly withdrawal proofs. So in Clementine, most of the BitVM-based bridge, excluding Uniswap, for example, what happens is you simply deposit your Bitcoin, and it got signed with something called connector UTXO. It connects that UTXO with the logic of the BitVM program so that no one can unauthorizedly spend that UTXO. And while withdrawing, operator covers this cost of people who are withdrawing from the chain, from his pocket, and then later it goes on chain, first off chain, then if necessary on chain, and says, I aggregated all these proofs. This is the latest Citrea proof. And I did all the withdrawals, and these are the proofs for withdrawals. And once all the verifiers are verified as proof, they simply sign a transaction and pay back the operator. But if they disagree, for example, the disagreement can cause from operator missed one withdrawal. It didn't cover a withdrawal specifically, and they can always go on chain and put a fraud proof saying that you didn't cover this withdrawal, you are not eligible for this amount, so I'm slashing you. That's very, very simply how Clementine work. But we have code available on GitHub. We have a blog post dedicated how Clementine works. It obviously changed a lot over the time because there was there's a BitVM 2, which we inherit some properties, but it is still most valid design that people can now read and even contribute.
Yeah, one of the like initially one of the criticisms of BitVM was like it's a cool idea. The fraud proof like process is so impractical, but we've seen BitVM 2 come out, which dramatically reduces the fraud proof size to is it 2 blocks or 2 megabytes? I forget.
So in one transaction you can disprove something. Before that it was 40 transactions.
Yeah.
So
and those have to be like there's a sequential transactions after one another.
Yes, in the worst case in BitVM 1 you have to do 40 transactions on chain to actually find the fraud. But right now what Robin does is very tricky stuff with signatures and like intermediary steps. And right now within a one transaction you can show that a computation done incorrectly.
And do you think, I mean, this is typically the case where, you know, new idea comes out, it's like we kind of wonder like how does it implement the current, you know, implementation out the gate is kind of clunky, but we've seen in just 6 months dramatic improvement on BitVM efficiency. Do you think we'll continue to see this? I would imagine that like as you guys work on the implementation and as BitVM research progresses forwards, we'll see further improvements. What are your thoughts on the trajectory of BitVM? Do we reach a point where BitVM actually becomes incredibly practical, like from a block space efficiency perspective?
Yeah, so like you said, it become like dramatically improved over the last 6 months. It was previously like gates, non-gates, like you do all the gate stuff and people couldn't understand what it means. Then they find a way to like build instruction set, which becomes developing much more easy. And now they completely shifted towards a ZK verifier built natively. So yeah, it is improving a lot, to be honest. Our long-term goal is to have a ZK verifying base layer. without fraud proofs, obviously. And if we can do it with a simple opcode, it is much more better than to take whole block space. So long-term goal for our company is to like somehow get a ZK verification done on the L1 natively. But if not, I think BitVM will continue to improve. Right now, if we have like one fraud-proof transaction, and so in two transactions you can settle whole L2, but it can take too much block. And I believe there will be further improvisations on script size to reduce this, maybe even to one transaction. If not, it can still make the script size smaller for the two transactions.
So where would you say, I don't know if you're even able to evaluate this, but where would you say you are in the implementation process for this ZK proof and the bridge design?
Yeah, so like you said, we have two components. One is the Citrea code base, which is sequencer, full node, and prover, and the other is the Clementine, and it is dependent on the BitVM. So we are one of the largest contributor of BitVM right now, and Clementine is also doing great progress. So testnet is coming very, very soon, I should say that. And other than that, the node software is like becoming much more production ready over the time. And Clementine, we are exploring new ideas, adding some new features. It is growing a lot, but on the other side, BitVM also making very like huge progress with thanks to like all side contributors. And we hope that like in a couple of months, it will become fully stable to deploy everywhere. Not production ready, most probably. Some people maybe even take risks, or some like us will wait for audits, or even maybe like do some audits internally. But yeah, I think we are improving drastically, and it is all open source. Everyone can visit, and they can just like see what's been built so far.
So one of the challenges, and this has been part of the BitVM discussion, and really a lot of the discussion on any kind of off-chain bridge, is the complexity and challenge of liquidity requirements. Because I see in the Citrea, in the Clementine implementation, you can only have set UTXO sizes. Use the example of 1 BTC. That to me seems like one of the the limitations from a liquidity standpoint. What are your thoughts on this? And just like maybe the current discussion of liquidity requirements in BitVM, and like, is this something that can be improved? What are your thoughts here?
Yeah, I think like liquidity management is obviously some limitation that BitVMs right now brings, BitVM-based bridges bring, like Clementine. But it is still way, way better than like how Lightning and Arc version 1 works, because it is like fully over-collateralized, getting payment channel done. But right now we are just depositing, and you need to find the liquidity once it is needed. And as an operator, you can find the liquidity, and if not, you just replace by some other operator. If everyone like wants to solve that, the possible solution is get a like ZK verification opcode and a recursive covenant, or CAT here. If we get that, we can get fully trusted rollups, which are obviously, I think, everyone will want in the near future. But right now, yeah, this is one of the main limitations that we have. But as a team, we are working hard to mitigate the risk with providing, getting like liquidity providers, getting all the, like deals done to provide liquidity if necessary. But in practice, I don't see this will ever happen. But if it happens, we will always have some insurance ready.
Yeah, we could just skip right to, I mean, you mentioned getting new opcodes in, one being a ZK proof verifier, and then one being something like opcat. I'm kind of curious on, I'll just jump right to the ZK proof verify, because until recently, I hadn't done enough research. I thought, oh yeah, there's just one kind of ZK proof verifier, but no, this is a conversation in development.
Yeah.
Do you guys have a proposed ZK proof verifier, or are you kind of in the R&D stage? Where's your head on this?
Yeah, it is internally in R&D stage, but yeah, there are multiple proof types in the world, maybe like even more than 100. It can be. Each is like very different than other. But I think for Bitcoin, with like a working group that we can include more people, we will come up with a universal proof system that every proof can eventually be represented. Right now, it looks like a gross 16 proof, which is the like smallest proof I think ever be done. It has some limitations, but eventually most proofs can be fit into a single gross 16 proof with some other off-chain overhead. But it is something very early stage, and we are still R&Ding, and contributors are also welcome. If they can reach me with some ideas, we can always include them to the like team chat and research and some ideas to like find the correct ZK verifier.
And then OpCat would, I understand, enable trustless bridging. Where's your head on OpCat? OpCat is an interesting one because, I know the wizards have been some of the technical critics of the existing BitVM implementation, but on the other hand, they're also some of the biggest proponents of OpCat, which would really unlock a lot of the like trustless bridging. Just thoughts on OpCat in general.
Yeah, OpCat, I think the main feature OpCat provides is to like Merkle inclusion proofs, thanks to its concatenation feature. And with that, you can build almost all of the like blockchain systems, because everything depends on Merkle trees. Withdrawal trees, deposit trees, state trees, they all depend on a Merkle tree. So if we get this verification, then once we like say verify the proof, then we can do all the proving of the like inclusion of withdrawals and other things. And other than that, I think just with OpCat we can also verify ZK proofs. But I don't know if it will like fit under 4 megabyte block size limit or not. But that's also still, I think, in R&D of some people.
One thing which has plagued rollups on other chains is this sequencer problem. Now, I don't pretend to be fully up to speed on like the landscape of sequencer discussion, but we have multiple design challenges when building a rollup. Sequencing being, I think, one of the more challenging ones to solve, because like on other chains, you've got a ton of capital working on this. You've got a lot of incentive to like improve the sequencer decentralization. Is this some? I mean, I guess the first question is: do you think that there are decentralized sequencers out there on other chains? And then, are there ways that Citrea could implement sufficiently decentralized or fully decentralized sequencing? What's this conversation look like?
So I think the main thing right now, people focus on more the like security of the ZK proving and like fraud proofing systems, not the sequencer, because sequencer eventually has to prove everything. So in practice and in theory, it cannot produce any invalid block. It can only reorg the chain for some time. That's a huge issue for sure. But initially, I think compared to like other things that we need to fix, it is something smaller. But yeah, we are still in R&D phase to how to decentralize sequencer. We have some internal proposals and experiments that we do with Tendermint consensus, how we can build a like peer-to-peer network between sequencers, and they can simply rotate the block production and have a consensus on soft blocks before proving the blocks. So it will give enough security for users with even the transaction volume is fairly large. And this is still in R&D phase. I know there are a couple of Ethereum projects right now spearheading this, like ZK Sync, I think, is one of the like leading ones in here. But we are also looking to their R&D documentation and code to like how we can do and get this and like build on Bitcoin. So this is something that we are still discussing, and it's an important point to address.
Yeah, so I've brought up rollups on other chains, and that it's interesting because it's coincided with a broader discussion, especially in Ethereum land, of like, what should Ethereum look like? Is this a rollup centric roadmap? What does this look like? But we're on Bitcoin now. Bitcoin provides more, I think, compelling decentralization arguments from a block production standpoint, although recently that's been an interesting sub conversation. We're going to pretend that didn't. We're going to roll the clock back a couple weeks. What do you think? How do you think rollups on Bitcoin? Actually, here's a better question. On the Gwart show, one of our other podcasts, Gwart was talking to Anatoly, the founder of Solana, and Anatoly says, quote, "I don't worry about another chain with 100 rollups. I worry about a chain with one rollup." What are your thoughts on this?
Yeah.
Do we see a dominant rollup emerge on Bitcoin? What
Yes.
are your thoughts?
So we are building the rollup first to actually like showcase what's been possible to build on rollups. With sidechains, we saw the low demand for that, like Stacks, Rootstock. For years they were kind of like ghost chain. They are mostly still ghost chains, and right now we are building one of the most like secure rollups and the most trust minimized L2 over there, except like channels like Lightning. Uh, and why we are building is simply provide some like ground for developers to build decentralized applications, Bitcoin-backed stablecoins, Bitcoin-backed loans, AMMs for BRC20 and like runes trading. And this will all become possible with Bitcoin security and using Bitcoin as a native token. So I think once people see that, they will become much more interested in getting some like rollups natively done on Bitcoin. I don't say it will become a like rollup centric roadmap. Bitcoin is like nothing centric, and I love it. But we will see some improvements that can also improve rollups on Bitcoin. That's the goal. And on Bitcoin, I also see before getting all this like enough flexibility on the L1 to build actually like fully trustless ZK rollups, I expect there will be one or two dominating rollups on Bitcoin because, for example, BitVM based bridge, like you said, has some liquidity problem that needs to be addressed, and small rollups with like small teams, non-experienced team, they cannot simply operate these kind of rollups. So our goal is eventually provide a base for other rollups. So instead of building L2s rollups on Bitcoin, they can build L3s on Citrea. They will still get like same security of trust minimized Bitcoin, but they can use existing tooling around Ethereum and Cosmos to like simply deploy these rollups. So they don't have to deal with BitVM and other stuff. We are dealing with all of that. The long-term goal is to like make Citrea the base of Bitcoin programmability, and it will become a like foundation for the world's finance. We will bring DeFi, we will bring liquidity, and applications can simply build natively on L2. If they want to customize, they can go L3s and build there.
That's a really good line in response to Ethereum's rollup centric roadmap is Bitcoin is nothing centric. That's a pretty banger line. And I would almost say maybe Anatoly thought he would be worried about if ETH had a single dominant rollup, but perhaps he should be watching out for Bitcoin in a future where there's some very effective rollups on Bitcoin.
Yeah, like with enough work, I think you can improve a single rollup a lot. Like if we can bring parallelized EVM here, and we will bring multi-VM approach here, and we will bring volition model here. So after that point, it becomes like almost infinitely scalable for L2 users. It doesn't matter like how big is that user base, but they don't have to go with other rollups once we have provided these features. And I think, yes, I believe that one single rollup providing full technical things that it can provide is much more better than having 100 rollups right now, especially on Bitcoin.
Yeah. So you say you say that it's very, very scalable. I'll try to be skeptical on this. Like, are there like certainly there are current limitations to what we like current implementation scalability, but like, do you think that a well-designed rollup, given some of the right tools, perhaps the soft work, could be infinitely scalable or near infinitely scalable?
Nothing is infinitely scalable. I wouldn't say that. I wouldn't say that line in this podcast, but I think with a like correct technology, it can be scalable enough to accommodate all the L2 users. Yeah, some users will continue to use Bitcoin L1, and they should. But if you want to have more faster and cheaper environment, and also you want to have Bitcoin security, you will come to the rollup L2. And at some point, it will become scalable enough to accommodate all these users.
I feel like a lot of my questions are saying, here's what rollups look like on other chains, and then what does something on Bitcoin look like? And I guess the other question is, and you hinted at this earlier, and I've heard you talk about this on other podcasts, is it looks like you're choosing to use a Bitcoin denominated base unit
Yes.
on Citrea, in contrast to the blockchains like Arbitrum and what all the other ones are, which have their own native token.
Yeah,
Talk to me about.
Mhm. I think other Ethereum L2s also using ETH as their native token.
Okay, they
But
are.
they
Okay.
also have other tokens who can facilitate the governance project.
Exactly. Yeah, they do inject some tokenization in there. And what I hear you saying is that Citrea will likely not include any kind of tokenization. Can you?
Citrea uses Bitcoin as the native token, so every application can work with Bitcoin.
And I hear you say that's because, and I agree with this, that any like introducing other tokens would compete with Bitcoin, the base layer asset, which is a losing battle. Could you just talk to me about the thought process behind that?
Mhm. Yeah, I agree with you. Like, so there are runes, BRC20s, which are like traded. They're mostly right now don't have any utility. And to be honest, like 99% of the tokens probably has no utility. But there can be some tokens that can have utility. But as long as they don't compete with the base layer token like Bitcoin, they should facilitate their trades on the L2s so that we can use L1 more efficiently. That's my goal. And using Bitcoin as a native token allows us to do multiple things. Very easy onboarding from Bitcoin L1. Getting this paired with all like BRC20s and runes to be traded on AMMs or like order book dexes. And the third thing I think most people omitting is onboarding new people to Bitcoin. If you just like open an L1 wallet, if you want to like be fully safe, you will probably like download one of the desktop wallets which looks very very ugly, and you have to use that. You have to store your seed phrases. You have to do everything. But on Citrea there will be like account abstraction powered wallets which can abstract all the complexities to the behind, so you can simply onboard users in a one click with less than 10 cent fees. Maybe they will buy their first Bitcoin here in a non-custodial way. I think that's more important than what Coinbase did, what all the exchanges did, and what Bitcoin L1 did onboarding people. L2s to onboard new people into Bitcoin is a new space that we are exploring, and we are very excited to onboard people to Bitcoin non-custodially. That's one of the key things that we are right now focusing on.
That's really cool. I get very excited hearing, bring more people to Bitcoin non-custodially in ways that they understand, remove the friction points. So I guess I'll start wrapping it up here. Where does Citrea go from here? You're working on the implementation. You are headed towards a test net, you say. What do the next, say, 3 to 6 months look like?
Yeah. So we just like last week released our like scheduled to testnet, what we need to do before going to testnet. That's one of the things that we can link through. And the other thing is right now, okay, product-wise, we are making a huge progress. Testnet is coming soon, and we are improving Clementine. We are contributing to BitVM. We are building the core Citrea software. But other than that, I also want to like touch on why this is needed from a user perspective or like everyday people perspective, because we think that Bitcoin should be the full global money, right? Full unit money. So in order to have that, you actually build an economy around it. Just doing medium of exchange or store of value even, it doesn't provide you anything to onboard new people to here and replace USD and Euro dominance around the world. In order to be happen, people need to engage more with Bitcoin using their other assets they already have, like USDT and USDC and ERC20s and Rune. They should come here, they should buy their first Bitcoin, they should create an economy around Bitcoin so that it can become an actual currency that can in the long term compete with USD. In order to help that, you can build Bitcoin-backed stable coins, which are pegged to dollar, but they doesn't have any like actual backing in the bank. Or even maybe you can build stable coins that is not pegged to anything. There's an interesting experiment on Ethereum happening called Reflexer, which acts like a token, stable coin, but it doesn't peg to any token. So it also performs very well against USD. And you can build it backed by Bitcoin. So it can, in the short term, it can even compete with USD globally. Options are like unlimited that you can build on Citrea. That's why we are excited, besides all the like products, cutting edge technology and other things.
It does seem like, the Bitcoin season 2 really does seem to demonstrate that Ethereum may actually have been the test net. We need to continue iterating on these ideas. Because there's
like
a lot of smart.
Since Ordinals, the progress is insane. Like you cannot
Yeah.
imagine. Like the progress is insane. I think no one has ever seen this kind of progress in any other ecosystem.
Yeah, I mean, your boots on the ground. Like you are on the forefront of the research side. I think a lot of people in the Bitcoin, the legacy Bitcoin talking heads, not very technical largely, and then the legacy Web3 crypto people are not really Bitcoin. But there's only a handful of people like you, I would say, who are familiar with the developer ecosystem. You sound very optimistic about it. Like, what is are developers flocking to Bitcoin? Is this actually happening? Is the narrative true that this is happening?
Like, I think since last year, I have seen many folks from Istanbul, Turkey, where I based, shifting from other ecosystems to Bitcoin. They built Ordinals marketplaces, they built wallets, they are building infrastructure projects right now. They are preparing to build on Citrea. So in Turkey, it's like emerging country dealing with high inflation, like bad management. Turkish lira against Bitcoin almost zero. So we have like enough, I think, exposure to the local ecosystem to see that the growth's happening on Bitcoin, not only from the user and volume side, but also the development side.
Well, that's really exciting. I love to hear that, Orkun. Thank you so much for joining me. Great conversation. I'm excited to check in on Citrea down the road in a few months and over the course as you guys go to testnet and mainnet. So thank you
Yeah,
so much.
I really enjoyed the conversation, both technical and non-technical stuff. And Citrea.xyz is where you can follow all the like socials and other stuff. And if you want to build on Citrea, if you want to use Citrea, just ping me and I would love to like help you through all the process.
All right. Thank you so much. We will circle back in a while. Thank you so much for joining Bitcoin Season 2. Make sure to check out other Blockspace Media podcasts, The Gort Show, The Mining Pod. Subscribe to the newsletter and follow our social media. You can listen to this podcast anywhere podcasts are streamed, Spotify, Apple, and on video on YouTube. We also do a live stream typically Thursday evenings, which is a more topical, quick hits. What are people in the Bitcoin and Ordinals ecosystem talking about? Without further ado, thank you so much for joining me for Bitcoin Season 2.